Okay. So this first one says the population of weights for men attending a local health club is normally distributed with a mean of 183, standard deviation of 28. The elevator in the health club is limited to 32 occupants, but will be overloaded if the total weight is in excess of 6,336 pounds. Assume there are 32 men. What is the average weight beyond which the elevator would be considered overloaded? So we would just take the total allowable weight and divide by 32. Good, we get 198. What is the probability that one randomly selected male will exceed his weight? He has to be less than this. So we're just saying, what's the probability that X will be greater than 198? So we're just going to use the normal CDF command. We're looking for a lower bound of 198, an upper bound of a very large number. Our mean is going to be 183, and our standard deviation is going to be 28. So if we paste that, we get 0.2961 to 4 decimal places. Now, if we assume that all 32 male occupants in the elevator are the result of a random selection or a random sample, find the probability the elevator will be overloaded. So we're looking for the average to be larger than this. This is just a specific X value. Now we're looking for the probability that the average will be larger than 198. So the only thing that changes is our sigma. Our sigma now, instead of using the sigma from the population, is going to be the sigma of the population divided by the square root of the sample size, which is 32. Whenever you're finding the standard deviation of a sample, it's going to be equal to the standard deviation of the population divided by the square root of n. So we're not going to change anything really except for the last thing, which was our standard deviation, which will be 28 divided by the square root of 32. We'll paste that. And so that means we will get a probability of 0.0012. Okay. And then you can use this answer to solve the next part. All right, so this says, suppose the weights of all boxes in a cereal in a home with children is normally distributed with a mean of 66 ounces, standard deviation of 9.2. 5 homes with children are surveyed. Let X bar be the average weight of all boxes. So which distribution does it follow? This is written in a funny way. It wants you to tell me which distribution. Well, it's going to be normal. And usually we say something like normal with mean of mu and a standard deviation of sigma, right? We would say X follows that. Here our mean doesn't change. Mean's still going to be 66. But our standard deviation is what I just said before. That's the standard deviation of the population divided by the square root of the sample size. So I assume they want you to figure out what that is. 9.02 divided by the square root of 5. 4.034. Right, it looks strange, but this is the same thing as writing it like this. X bar follows the normal distribution with a mean of 66, standard deviation of 4.034. Okay. 25. Time required to assemble a single PlayStation 3 is approximately normal. Random sample of 17 PlayStation 3s is selected. Find the minimum assembly time of the upper 10% of average assembly times. First thing we want to notice is that the standard deviation of the sample is equal to the standard deviation of the population divided by the square root of 17. So we're looking for the value that cuts off the upper 10%. But when doing this, the calculator always wants values less than some quantity. So we're going to use the fact that it's greater than the bottom 90%. So if it's the upper 10%, it's the same thing as cutting off the bottom 90%, because that's what the calculator wants. So now if I have the percentage and I want to find the value, I'm going to use the inverse normal. Area, when they say area here, that means area to the left, so that's 0.90. Our mu is 15.35. Standard deviation is 1.6 divided by square root of 17. We enter that, we get 15.8473. Okay. And the last one. Company produces steel rods. Sample again, which is the average length separating the smallest 5%. So the 5% is going to be to the left. So we're just going to do this again. Inverse normal. The area to the left is 5% or 0.05. Mean is 246.3. Standard deviation is 1 divided by the square root of 17. So we get 245.9. 245.9.